Yeah, so in our previous discussions, we looked into your UAT, right, which was your uh, user acceptance testing. Now, any clue that what we are left with?
Post deployment activities.
Right. So now we went for UAT, will be going for deployment, and now we look for post deployment activities. That means we look for the regression part. So whenever my software regresses, we'll go ahead with some kind of testing. Right. So these are the topics which you've covered, and let's focus on regression testing today. Right. So to start with, what we have is let's see that uh, before going into regression testing, let's see what basically the maintenance is, because that would be your part of it. And what we have is that when we are bringing any change to the application post deployment, that can be due to adding of some extra functionality, or that can be due to some or the other errors which has been observed by the end user, and end user has reported some or the other issues with the application which we have deployed. So we need to go for something called as software maintenance, right? So what we have is, as a basic definition, that software maintenance in software engineering is the modification of a software product after delivery, right? So this is something which is crucial to correct the faults, to improve performance, or to improve some other attributes, right? So this is something which is your software maintenance. And we have like some categories of software maintenance. So what we have is, we'll see these things one by one in the upcoming slides. So what we have is, we have some options, like we have corrective maintenance, and we have adaptive maintenance, we have perfective maintenance, we have preventive maintenance as well. You might have got some basic idea about these things just by looking at the title, right? So just by looking at the title, we'll cover one by one. Now, coming back to software maintenance part, so there will be, n number of reasons due to which we bring some changes to the softwares, right? That can be, client's request. My client has requested for some changes, and for that sake, I need to bring the changes, or I need to go for the maintenance. And yeah, competitive market, right? So if I observe that, okay, there is another product in the market which is also delivering the same kind of functionality, or is serving the same kind of purpose which my product is serving, so definitely I need to bring some changes to my application in order to keep my position intact, or to get some more clients. Then maybe some structural changes are there in the application. For that sake also, I may need to bring some changes. Additional functionality if I'm looking for, then also I need to bring some changes, or I need to go for software maintenance, or the client reports some bugs. In that case also, I need to go for maintenance as well. See, thoroughly testing is already we have done, but still the probability is, or there are chances that once again we may still encounter some or the other issues with the application, right? For that sake, I need to go for maintenance, and that's what we said, that okay, these are some of the categories of the maintenance: the corrective one, the adaptive one, the perfective one, and the preventive one. Right. So these are some of the categories. Now, the first one is the corrective maintenance, where the changes made to correct a software product or a system after the failure has been observed. Right. So we have observed some failures. I need to correct those things. So I go for corrective maintenance as well. So usually done after the release, right? So maintenance is like, of course, that would be a post release kind of activity or post deployment kind of activity. So one is like we need to correct a product, so I'll go for corrective maintenance in this case. Another one is like, okay, let's continue some more discussion on the corrective one. So firstly, it is impractical to exhaustively test a large software system, right? We gave some efforts. We went for bringing the changes to the application, and we went for testing the product as well, but still we might have missed some or the other things, right? So that's why we say that, okay, this is something which is impractical in order to exhaustively test a large application system. So therefore reasonable to assume that any large system will have some errors, right? Any large systems will have some errors. So testing should be thorough and like thorough for common cases. So errors likely to obscure. Right? There are chances that some or the other errors may obscure. In that case, I need to go ahead with corrective maintenance. Next one is your adaptive maintenance, right? So this includes basically the modification and the updation that applied to keep the product software product up to date, right? So changes made to achieve continuing compatibility with the target environment or the other system or product. Right. The world keeps on changing. The technology keeps on changing. It keeps on upgrading. The business environment keeps on changing or getting upgraded. So I need to look for these changes as well. Recall the initial days, right? Some of these weird devices were only available for Android platform. Now these wearable devices are available for like, both the devices, whether it is Android platform or iOS site, right? So in that case, it's available. So I need to look for the changing technology. I also need to look for the business environment, right? So here also I have to go for adaptive maintenance in this particular case. So the reason being that the system don't function in isolation, right? So my system has to interact with other outside components, right? In that case, my system will always not work, and give you desired results in isolation. It needs to interact with the outside world, outside technology, outside platform, outside environment. For that sake, I need to adapt. Right? I need to go for adaptive maintenance. So my typically these systems, right, will be interacting with your operating systems, your DBMS, your graphical user interfaces, some or the other network protocols, and some other external software packages, and not only software packages but some hardware platforms as well. And in order to adapt those changes which are there in your DBMS or your graphical user interface or the network protocols, I need to adapt, right? I need to go for maintenance. I need to adapt these things. So in the industry, IT industry, any or all of these may change over a very short period, typically like 6 months or so. And for that sake, once again, as I said, we'll keep on updating ourselves. I'll keep on going for maintenance. I'll keep on going for regression testing. Regression we'll talk about in the coming slides. Next is perfective maintenance, right? So this basically includes the modification and the updation done in order to keep the software usable over a long period of time. So it includes like bringing some changes to the features, right? And it's like changes made or designed to improve or add some capabilities, right? I'm trying to bring some perfection. So it's like I'm trying to enhance some features. I'm trying to add some new features. Right, these are some of the reasons for which I need to go ahead with this perfective maintenance. I need to improve the application, right? And this basically is directly indirectly pointing towards that, adding some features or so on and so forth. So users and marketers are never satisfied, right? So in that case, I need to go for this kind of maintenance where, uh, in order to fulfill the demands of the users and the marketers, I'll go for perfective maintenance. So even if a system is widely successful, someone will want a new or the enhanced feature added to it, right? So iOS, let's say, right, is successful, right? I still people go for updating it, right? We see a lot amount of users with Android platforms, right? Still, we keep on looking at that. Okay, what's new in the latest release, right? That kind of thing we observe, and sometimes there will be impetus to alter the way to a certain component or the system works or its interface works, right? So I definitely go for bringing the changes. uh, that can be overall functionality. It can be even if I'm bringing a new thing in your graphical user interface, so that will also be included in case of perfective maintenance. The last one is your preventive maintenance. That basically includes modification and updation to prevent the upcoming future problems of the application. So basically, it aims to attend the problems which are not significant currently, but may cause some serious issues in the future. So changes made to increase the robustness, maintainability, portability, and other features. So increasing the software maintainability or reliability to prevent the problems in the future. Right. So I'm trying to prevent it, right, well in advance. I'm trying to prevent it well in advance, that okay, in future I may not face issues associated with the application. So sometimes changes are needed for entirely internal reasons, right? So I may update the application well in advance just to keeping a point in mind that the kind of problem we face in Y2K, right? So let me update it well in advance. And such changes have no direct effect on the user, but lay the groundwork for the easier maintenance in the future. And alternatively, such changes may improve the reliability or provide a better basis for the future development. So that's what the preventive maintenance is. Now let's talk about your structured versus unstructured maintenance. So from the title itself, you might have got the idea that in one thing it will be a systematic approach, and in other one it will be not that systematic or the formal approach. So unstructured maintenance waits straight into the source code, right, and will bring the changes based on that particular thing alone. Whereas in case of structured maintenance, it examines and modifies the original design and then rework the code to match it. So it clearly, the structured maintenance is more reliable and usually more efficient process. And unfortunately, it's not always possible, right? So I may not have that much amount of time to go for all those documentation parts as well. So I may directly jump into the code, bringing direct changes to the code. Now next is your software maintainability, right? So this is the ease with which software can be understood, corrected, adapted, or enhanced. Right. So I took this particular statement from our Pressman reference book. Now, enhanced by good initial design and understandable software structure, the maintainability factor becomes high. Comprehensive and accurate documentation, that includes your design documents, and obviously the use of standards, that means the design, language, coding, etc. Then it's like availability of extensive test cases. So that's the part of your software maintainability. See, everything has a cost. So if I'm going to maintain my software, that would be a costly affair. That I'll talk about the cost related to maintenance separately. Now, these are some of the problems which are associated with the maintenance, and what we do is that we try to sometimes address and we try to sometimes ignore these problems, right? So inadequate documentation of software evaluation is something which is a major cause of concern right from the beginning of, or right from the initiation of a particular project. If I'm not going for the proper documentation, then definitely what I'm going to face is I'll be facing several issues in case of the maintenance part. So inadequate documentation of not only software evaluation but also for the software design and the structure creates problem when we go for maintenance, because I may not be able to actually track it properly. Right? That's why I need to have a proper documentation for anything and everything in software development lifecycle. Then we have like loss of cultural knowledge of software due to staff turnover. Like old people leaving, new people joining, that also creates an issue because the new people might not be that much accustomed to the application on which we are working. Lack of allowance for change in the original software design. Yeah, so I may have a company which might be rigid and that may not prefer to bring some changes to the software design, whereas the current time demands to bring some changes to the overall software design, the original one. So there also I may face issues. Then your, yeah, maintenance is something which is unglamorous and maybe viewed as a punishment task, right? See, reading someone else's code itself is a painful thing, and then reading it, understanding it, and then bringing some changes to it, so that becomes a very painful task. That becomes a very painful task. On top of it, we have uh, the maintenance side effects as well. So, like any error or the undesirable behavior that occurs as a result of modification to a system will be the side effect of my application. So, we can have a coding side effect, I can have a data side effect, I can also have the documentation side effects as well. So, all these things I may have to face if I go ahead with maintenance part, right? I may have some or the other ripple effect which may arise just because of bringing some changes to the codes, or maybe some alteration to the code which has resulted into modification to the some data which is stored, or the documentation part, we brought some changes to the documentation just because we brought some changes to the product, so that may result into the documentation side effects as well. Sorry. Now, before focusing on regression, let me also have a discussion on the cost of maintenance, right? So everything has a cost, right? So maintenance also has a cost associated. So, reports normally suggest that maintenance can have as much as 60% of the overall entire cost of the software process life cycle. Right. So 67 for the maintenance, testing for 15%, implementation for 7%, right? Designing. Here I'm including coding in the implementation part as well. Designing nearly 8%, requirements nearly 3%. Right, so that's just imagine how much cost is in. That's why, see, coming up with a product will be like one time cost, but maintenance will be like for years to come, right? So that's why the overall cost in the maintenance is very high. Every time my client asks for a new functionality, I'll go for maintenance, I'll charge. Right. So what we have is for maintenance, what we need to do is we need to go for some of the activities, right? Your maintenance activities. So maintenance activities will be identification and tracing, tracing the issue. And once we have identified, I'll do the analysis part, that okay, whether this particular thing needs to be addressed or not. Then I'll design it, I'll implement it, I'll go for system testing, I'll go for acceptance testing. Once again, I'll go for delivery of the modified project. And afterwards, I'll go for maintenance management. That means whatever changes we brought, we have delivered it, and now I need to go for managing those things. I need to go for managing those things. Now let's now focus on your regression testing part, right? Once again I'll cover this particular thing, underline it to give you an idea that okay, there is something which is a new thing. Now, so a system is said to regress when a modified component fails, right? And when a new component causes failures in the unchanged components by generating some or the other side effects. So these are the two instances where a system regresses. So the regression testing is done to ensure that enhancement or the defect fixation made to the software product works properly and it does not affect the existing functionality. Right, the changes have not brought any ripple effect to the overall working of the application. So the regression testing is also known as selective retesting. Post changes, I'll selectively apply some or the other testing technique. So it's a selective retesting. So this is a definition which I lifted from IEEE Software Engineering Glossary. So it says that regression testing is the selective retesting of a system or component to verify that modifications have not caused unintended effects and that the system or component still complies with the specified requirements. All right, that's what your IEEE software engineering glossary says. Now let's see some basic purpose of regression testing. So the changes or the additions made to the software products work as designed or not. The changes or the additions do not break something that was already working fine and should continue to work as it is. Plus, the bug fixes for which we have gone for the regression do not create any side effects. Right. So these are the purposes of regression testing. Now let's talk about types of regression testing. One is like your regular regression testing, another one is your final regression testing. So what we have is, in case of regular regression testing, this is done between the test cycles to ensure that the defect fixes that are done and the functionality that were working with the earlier test cycle continue to work. And a regular regression testing can use work more than one product build for the test cases to be executed. Now, next is your final regression testing. So this is done to validate the final build before release, and your configuration management manager delivers the final build. So this is your final regression testing. So what we have is, let's see uh, the types. One is your regular, another one is final. What we do is we select retesting to ensure the defect fixes work and there isn't any side effects. Defects creep in due to the changes, and the defect fixes may cause existing functionality to fail. And when to do it? When set of defects fixes arrive after the formal testing for completed areas and performed in all the test phases. So when is the regression testing done? In case of software maintenance, in case of rapid iteration development, and in case of first step of integration, and for compatibility assessment and benchmarking. Also, your regression testing is done in following situations: where the reasonable amount of initial testing is already carried out, a good number of defects have been fixed, and the defect fixes that can produce the side effects are taken care of. So regression testing can be done at different levels. One is at the unit level. That means one unit was deployed. We brought some changes. Let's go for regression testing. For reintegration, it can be done at a functional level. It can be done at a system level. See, each time why we are seeing this, because there is a possibility that a function was deployed and then we got to know about some or the other issues. So who all perform this software regression is, like, we see developers, we see test engineers, we see quality analysts and test engineers. So developers will be like regression testing at the unit level or the integration level. Test engineers will be doing regression testing at the function level, and QA and test engineers will be doing regression testing at the system level. Right, so these are some of the types that, okay, we have several test cycles going on. We had the build one with all the bug fixes and all, and once we have gone for the new features, we went for a test cycle. Right, now build 2 came up, we went for regression. We added some regression, we added some features to it, we went for test cycle 2. We brought the regression once again. We added some features. We went for test cycle 3. We went for the final regression. If there isn't any further build available, then it would be your final regression, or else we'll keep on continuing this particular process. So this is the software regression process. That means step 1 is software change analysis is done. Software change impact analysis is done. Then we define the regression test strategy, define the select and reuse test cases to form a regular regression test suite, perform the retesting at a different level. That can be at the unit level, integration level, function level, or the system level. And at the end, report and analyze the regression test results. So this is the overall software regression process. Analysis is done, impact analysis is done, strategy is defined, test suites are built, running the regression test at different level, and reporting it. So some of the problems in software regression testing is like how to identify the software changes in a systematic way. Right. So what we have is we need to have the requirement specification changes. We need to have the design specification changes. We need to have implementation changes. We need to have user manual changes. We need to have environment or technology changes, and we need to have the test changes. So all those things should be there on record. Then only we'll be able to successfully go for regression testing. Then we have like how to identify the software change impact in a systematic way. So I need to have the requirement impacts, I need to have the design impact, what all impacts these things are bringing, the implementation impact plus the user impacts plus the test impacts. Now the point is, uh, you know, any doubts up till now?
So any quantitative way in which we can tell a change brought about is better than the previous.
Okay, so what we have is we have those impact matrices, right? We know the initial stage, we know the final stage, come up with the impact matrix, and then finally take a call on it. Any other doubt? See, I see today I see a good number of people attending the class. Any other doubt? No? Okay. So these are some of the major regression testing problems. That means how to use a systematic method or to tool or to identify the change software parts, to identify the software change impacts, to identify the affected software test cases, to reduce the retest suits, to select the test cases in the test suits. So these are some of the major regression testing problems. Some of the major challenges in software regression testing is to minimize the retesting effort and to achieve the adequate testing coverage as well. Every time I need to minimize the efforts. Right. That should be the aim. That too, efforts for retesting this time. Efforts for retesting this time. So these are some of the references for this particular set of slides which I have added. So any doubts up till now? Okay, so let me take another small topic. So what we have is we talked about all these things, right? Let's talk about I-18N, which is your internationalization testing. Why I-18N? Because in between I and N, what you see is the length to be 18. So internationalization testing is done for the internationalization to ensure that the software does not assume any specific language or conventions associated with a specific language. That means my application should be available for the all set of languages. So why we need to go for internationalization? So ability of a software product to be available and usable in the local languages of different countries significantly increases its rate of adoption. I'll give you some examples as well. Right. So these are some of the softwares which are ready for the market. So just see the options available for a particular application. Right. So just see this. I took this screenshot sometimes, long time back, I guess. So Facebook started giving options to post in various languages, like various local languages, right? So that kind of feature we have, that has only resulted into adoption of this particular product to further new set of users. So all the activities to make a software available for international markets, that includes both deployment, development, and the testing activities. Next term is your localization, which is L10. So translation work of all the software resources to the target language and the conventions, and usually done by the language experts, right? So this is something which is done by the language experts. So next is your globalization testing. So this is a term used to mean the internationalization and the localization both. This is the test phase, right, for the internationalization testing. So what you can do is you can enable the code, enable the testing, go for the local testing, testing and validation, go for looking for the fake language test, look for the final language testing, and release the version. This will be like the English version, right? Then in case of international versions, what we have is we have the message consolidation, we have the message translation, then we can include the message into the product, then we can go for localization testing with the help of the language experts, and then we'll release the international version for that particular product. Right, so this was about your internationalization testing. And any doubts up till now? Any doubts up till now? Okay, fine. So what we have is we had a discussion on these two topics, and then we